kiddos. This activity is called multiplication mix-up. It's gonna kind of test your ability to know your multiplication facts to solve a bunch of problems. So this is what it's gonna look like. You are going to have a table here with triangles along the top and along the side, and you are gonna have to fill in this table with factors and products. Okay, now remember, in a multiplication problem, the factors are the two numbers that are multiplied together, and the product is the answer. Okay, so the triangles are going to have the factors. The factors are going to go along the top and along the side, and the squares in the table are going to be your answers or your products. Okay, now the rule is on this one, you're going to use each factor, 3, 4, 5, 6, and 7, one time each across the top and down the left side. Okay, so the trick is putting those numbers in the correct places so that your products match. Okay, now some strategy. The first thing I usually look at is, are there any rows or columns? Remember, rows go across, columns go up and down, that have two numbers in them. Okay, so like if I look right across here and I've got 35 and 15. Well, 35, using these factors, I can make it one way, right? 7 times 5. But the question is, which triangle is going to be the 7 and which triangle is going to be the 5? But if there's a second number in that row, that helps me figure that out, right? So like if 15 is over here, if I go straight across, I'm thinking about my factors. If I put a 7 here, then that means every product across this row has to be a multiple of 7. 35 is, right? Because we can do 7 times 5. But 15, that isn't. I can't multiply anything times 7 to give me 15. So that should tell me that in this triangle, I'm going to put a 5. It's an ugly looking 5, but it'll do. So if the 5 has to go there, I know my 7 has to go up here. Okay? Another gross looking 7. If I have my 5 here, every time I put a factor in, it's going to help me solve more stuff, right? So if my 5 I know goes there, and I go across and 15 is here, what number times 5 gives me 15? It'd have to be 3, right? Okay. Ew, I don't know what happened. Looks fine. So now I've got a 3 here, I got my 5, my 7. So now that I've added a 3 here and I go down my column, I see I've got 21 in this column. If I know my factor here is 3, I go across 3 times what equals 21? That would have to be 7, right? So where can I go now? Well, one thing I could do is start filling in the numbers, my products that I know. So if I got like for example, I did a 7 and a 7. So 7 times 7 would give me what? What could I put in this spot right here? 7 times 7. It's a tricky one. I'm sure you figured it out already because you're so smart. That would be 49. That'll work. But okay, now we're kind of in a tough spot because we don't have 2 of anything anymore in a row or a column. We had our 2 across, 2 down, 2 down. So let's look down here at 36. I bet we can figure out what our 2 factors are of 36, even without anything else in our rows and columns. Keeping in mind the factors we can use, 3, 4, 5, 6, 7, how do we make 36? Now, I can't do 1 times 36. They're not part of my factors that are available. I can't do 2 times 18. I can't do 3 times 12. I can't even do 9 times 4, right? Because 9 doesn't exist on my factors that are available. So what's the only other way to make 36? Figure it out. It's got to be 6 times 6. So that's another big one that you can look for. These are called square numbers. Square numbers are numbers that you can get to by multiplying the same number by itself. So like 6 times 6 makes 36. So when you have those in puzzles, then it's pretty easy because you know the same 2 numbers are going to go in your 2 factor spots. Okay? And then my last one that I wanted to give you a hint on is 12. Okay? Again, looking at our factors, we can't do 1 times 12. We can't do 6 times 2 because 2 isn't an option. So what's the only other way to make 12 using the factors that are available to us? 3 and 4, right? 3 times 4. So then the question is, which spot gets 3 and which spot gets 4? Well, because we can only use each factor once across the top and once across the side, if I've already got a 3 right here, I can't put another 3 here, right? That'll give me 2 3s across the top. That means this factor has got to be 4, and this factor has got to be 3. Does that make sense? Again, it's that problem-solving process of elimination, okay? And once we're here, now the easy part to figure out our last one is, what are we missing, right? If our factors are 3, 4, 5, 6, 7, which one isn't across the top? That's got to be a 5. And 3, 4, 5, 6, 7, what am I missing over here? That one's got to be a 4. And once I have all those put in, now I fill in my table with my multiplication facts. So here I'd say 6 times 4 is 24. Going across, this would be 4 times 7, 4 times 5, 4 times 4, 4 times 3. So then you're going to fill in the rest of this table. And that is how each of these are going to go. Okay? So, I hope you enjoy it. I love these puzzle type things, so have fun.